This here is a special molecule called a fatty acid. It's a collection of carbon atoms, hydrogen atoms, and oxygen atoms all stuck together in a specific pattern. Fatty acids are one of many complex molecules that living cells use inside their bodies. They build fatty acids with atoms they get from their environment. Scientists used to think that living cells were the only things able to consistently build fatty acids, but check this out. Lab experiments have shown that if simple common gases, carbon monoxide and hydrogen, are heated up with minerals like those found in the Earth's crust, a variety of complex carbon molecules, including fatty acids, begin to grow. Living cells are not needed. This can happen naturally in underground chambers, heated by the Earth's magma. As pressure builds, these molecules can belch up into pools of water, where a simplified version of natural selection then takes over. Most particles blasted into water will either float or they will sink. Nature selects against them staying in the watery environment. Fatty acids, however, remain suspended in warm water, growing in number as the cycle repeats. When fatty acid concentrations are high enough, they bunch together, automatically self-assembling into a stable ball. This happens because water molecules are attracted to the oxygen heads of fatty acids, sort of like a magnet, but water repels their oily carbon tails. When fatty acids pass near each other, their tails are pushed together by water, eventually forming a ball. As fatty acid collections continue to increase, they join together to make large skins. If fluctuations in these skins happen to make the edges touch, water forces those edges to fuse together. The end result is a stable hollow container, similar to the membrane or skin of a living cell. These containers have a brand new ability. They can trap other molecules inside, acting as an entirely new environment for chemical evolution to continue working within. It's important to note that these membranes do not qualify as living creatures. They can't reproduce on their own the same way living cells do. That said, the development of these membranes, along with many other molecules and chemical systems that scientists have observed, demonstrate an extremely important principle. Chemical evolution can give rise to new characteristics and abilities.